Good morning. I'm Matthias Preindl. For those that don't know me that well, I'm an assistant professor at the electrical engineering department here at Columbia University. And the laboratory at this point, it's located in main campus, just in the building beside us. Currently, we have 4 PhD students, 2 master's students, and I'm co-supervising also some students. And we have also some undergraduate researchers in the laboratory based on projects. Currently, the laboratory is working on essentially on advanced control of motor drives and power electronics. We're talking about optimal control and nonlinear observers. And then we have also, we're doing some power electronic designs, kind of focused on wide bandgap, high-frequency converters. Our applications are mainly electric drivetrains at this point because of the high interest in both academia and industry. That means also working with storage to some degree. And we are interfacing, or we are working also with renewable energy and smart grid pretty much on where they intersect with the previous 2 applications. Today, we gathered to talk about electrified transportation. We are very interested, or there is steadily increasing interest in transportation. Usually when we talk about transportation, we mean one of these 4 categories: electric vehicles, electric trains, more electric ships, and more electric airplane, or more electric airplane. In terms of the challenges, just as an introduction to the discussion today, in general, the challenge is emissions and how energy is produced, in particular the transportation sector. So in terms of emissions, the world, or most countries have agreed and ratified Paris Agreement, which means that we need to at least stop increasing the CO2 emissions worldwide, such that we can achieve a 2%, a 2-degree increase of temperature, average global temperature over pre-industrial levels. And one of the challenges is the energy. How do we use energy? And this is one chart that shows how the prime energy is used. We are talking about solar, nuclear, hydro, wind, geothermal, natural gas, coal, biomass, petroleum. And they're used in electricity, residential, commercial, industrial, and transportation sectors. And above all, transportation, we have here the energy that is actually used, that is useful, and the energy that is rejected, that is simply wasted in terms of heat. And above all, the transportation sector, actually there's a significant higher portion that is actually wasted at this point. So today, we have speakers here that either directly or indirectly address these challenges to promote systems that are either directly addressing this or which are enabling those systems. And to briefly go over the forum, we are initially talking about transportation systems. First about applications of microgrids to transportation. Then we have a talk about hydrogen vehicles, and regenerative braking in electric rail. Then we have a coffee break. After the break, we talk about power conversion. We have a talk on repetitive control, silicon carbide as a novel switch technology that enables higher performance, higher efficiency vehicle drivetrains, and then a control talk. Then we have a lunch break of an hour. And in the afternoon, we go over energy storage. We have talks on battery model, physical battery modeling, and then multi-life opportunities of electric vehicles for in-grid applications. In terms of future trends, that's our last after the afternoon coffee break. We have 2 talks, one on the future of the electric vehicles and grid, and a talk on future of batteries. In terms of these forums, I would like to say special thanks to both the electrical engineering and the mechanical engineering department that are permitting us to offer this forum for free and to provide also refreshments. Special thanks also to electrical that permits us to stream this forum online and to make it available on the internet. Okay, with this, I'd like to open the forum, and I think we can start with the first talk.